This first set of PowerPoints are going to look at body tissues and their characteristics. First of all, as you know, there are 4 different basic types of tissue in the body: epithelial tissue, connective tissue, muscle tissue, and nervous tissue. Each of these types of tissue have their own characteristics. Tissues make up organs. Typically, you can find all 4 types of tissues within an organ. For example, the skin is an organ. In the skin, we have epithelial tissue on top of the skin. So the surface of the skin is lined with epithelial tissue. Below epithelial tissue, there is always connective tissue. This will be connective tissue underneath the epithelial tissue of the skin. Muscle tissue is present in the form of small muscles that attach to hair. Nervous tissue is present in the form of receptors. Another example is the stomach. If we take a cut through the stomach, we're going to find all 4 types of tissues. Again, epithelial tissue is lining the stomach. Underneath epithelial tissue, there is always connective tissue. In the stomach, below the connective tissue, there are layers of muscle. So we say that the walls of the stomach are made of muscle. Wedged between muscle and in the connective tissue, we're going to have nervous tissue, which innervates muscles and glands. Another example is the heart. Again, the heart is going to be lined with epithelial tissue. This will be the epithelial tissue lining. Below epithelial tissue, there's going to be a thin layer of connective tissue, so thin we cannot really see it in this particular picture. Below this thin connective tissue layer, there is a very thick muscle layer. So again, the walls of the heart are made of muscle tissue. And then we have, again, layers of epithelial and connective tissue. Nervous tissue will be in the form of nerves that are going to innervate the muscles of the heart. So most organs are going to be built by all 4 types of connective tissue. We're going to now look at the first of these 4 types of connective tissue, epithelial tissue. There are 2 types of epithelial tissue. We find epithelial tissue lining the surface of organs, both external and internal surfaces. So one word that you often find describing epithelial tissue is the word lining. So epithelial tissue lines or covers surfaces. Sometimes we call it the carpet of the body. Epithelial tissue also makes glands, which secrete substances like hormones, sweat, oil, etc. So epithelial tissue comes in 2 forms: the epithelial tissue that lines the surface of organs and epithelial tissue making up glands. Characteristics of epithelial tissue. First of all, if you think of epithelial tissue as a carpet, then you'll realize that epithelial tissue has polarity, meaning it's going to have 2 environments. Just like a carpet has 2 environments. The top of the epithelial tissue is going to be on the surface of the organ, and we call these the apical surface of the tissue. The opposite side of the tissue is going to be sitting on what's called a basal membrane, If this was a carpet, this would be the carpet pad. And the basal membrane connects epithelial tissue to the tissue below, which is connective tissue. So epithelial tissue has polarity because it is facing it has two environments. The top environment is the surface, the apical surface. The bottom environment is the basal membrane. Another characteristic of epithelial tissue is that it's cellular. It is made by cells. So what we're going to find with epithelial tissue is cells next to cells, on top of cells, below cells. So all we find are cells closely packed together. This next characteristic is very, very, very important. Epithelial tissue is avascular, meaning no blood vessels. This is important because it provides some of the reasons why epithelial tissue is a protective tissue. If you think about it, if you have a thick layer of epithelial tissue like we have in the skin, there are no blood vessels, so that substances like bacteria cannot easily go through these layers and gain access to deeper parts of the body like they would if there were blood vessels in epithelial tissue. So by epithelial tissue being avascular, it forms a seal. At the same time, because there are no blood vessels in epithelial tissue is dependent on connective tissue for support. So the connective tissue underneath is going to provide the nutrients and oxygen needed. Connective tissue does have blood vessels, and it's going to remove waste. So connective tissue is always found underneath epithelial tissue because it provides support to the avascular epithelial tissue above. Finally, epithelial tissue has a high rate of regeneration, meaning that it is going to heal quickly and easily. When it comes to functions of epithelial tissue, now there are many different types of epithelial tissue, we're going to see that, but the basic functions are going to be protection, especially that of thick epithelial tissue, secretion of substances. Remember, epithelial tissue makes glands which secrete substances. Absorption of substances. So if we have a tissue that's on the surface of an organ and the tissue is made of cells, those cells will be able to absorb substances from the surface and move them to deeper parts of the organ. So absorption will be another function. Epithelial tissue is going to form barriers that are going to separate environments in the body. Now, classification of epithelial tissue. Epithelial tissue is classified based on two criteria. The first criteria is the number of cells. And based on that criteria, epithelial tissue can be simple if it's made by one layer of cells. Or it could be stratified if it's made by more than one layer of cells. So those will be the very first basis for classification of epithelial tissue, the number of cells, of cell layers. One cell layer is called simple, multiple cell layers, more than one, is called stratified. The second criteria for classification will be the shape of cells. Based on the shape of cells, the tissue can be squamous if the cells are flat. So if we have simple squamous epithelium, we have one layer of flat cells. The tissue could be cuboidal if the cells are square. So based on the number of cells, if there's one layer of square cells, the tissue is going to be simple cuboidal. The tissue could also be columnar. If there is one layer of columnar cells, we're going to have simple columnar epithelium. Among simple epithelial tissue, there is also a subcategory of columnar called pseudostratified. Pseudostratified epithelial tissue is columnar epithelial tissue in which the cells are of different sizes and are at different levels, which gives the illusion of being stratified. But it's not. It's actually simple tissue, one layer of cells that have different sizes, so it gives the illusion of stratified. That's why it's called pseudo-stratified. Stratified epithelial tissue, I'm going to put it here, stratified. We're actually going to have two types that we're going to look at. The cells, we could have squamous cells, in which case it will be a stratified squamous. Stratified epithelial tissue looks at the cells on top of the tissue, not below the tissue. So a stratified squamous epithelial tissue is going to have several layers, more than one layer of epithelial cells. And the layers that are going to be flat are going to be the ones on top in the apical surface. So those will be the squamous cells, and that's why the tissue will be called stratified squamous. The cells could be a square, so we could have more than one layer of square cells, and then we will call that a stratified cuboidal epithelium. However, we're not going to look at a stratified cuboidal, so you don't have to worry about that type of stratified epithelial tissue. The cells could also be columnar and in more than one layer, in which case they will be stratified columnar. Again, we're not going to look at a stratified columnar tissue. We are going to look at another type of stratified tissue called transitional. So notice that the name does not follow the rules, but this is nonetheless stratified epithelial tissue. Transitional epithelium consists of circular cells, round cells, more than one layer, which can transition in shape from being round to being flat. And that's why it's called transitional.